Good morning, everyone. My name is Nishita Kumari, and I am currently pursuing diploma in computer science and engineering in Government Women's Polytechnic at Jamshedpur. Today, my topic of presentation is IoT-based home automation. So, the first question arises: what is IoT? The IoT is more than a new generation of the internet. It is the next technological revolution, horizontal and global, in which we will finally see the digital and physical world blended. Now, we will move on to the next slide, that is acknowledgement. First of all, I am glad to take this opportunity to acknowledge everyone who helped me in developing and designing my project on IoT-based home automation. I would like to extend my thanks to EMERTXE team for their valuable guidance and providing all resources for development of the project. I would also like to extend my thanks and gratitude to my teacher, Mr. Somnath Maiti, for his consistent guidance, without whose support the project would not have been possible. Now, we will move on to the next slide, that is the table of content. It basically consists of topics that have covered during internship. C and C++ programming language, introduction to IoT and embedded systems, requirements for projects, tool used, home automations that include garden lights, temperature system, and water tanks. Then I will show demo of my project and end with conclusion. First topic, that is C programming. So, what is C programming? C is a general purpose programming language invented by Dennis Ritchie at the Bell Laboratories in the year 1972. Despite being the old language, it's very popular. C is considered as middle-level language because it possesses the qualities of both high-level and low-level languages. For example, it has most of the control structure present in a higher-level language. It also has macroprocessor, pointers, string, etc., which resembles the assembling language, that is lower-level language. The language is for programmers intended to be used commercially and are designed in a way to address real problems involved with writing code. Now, let's come to the subtopics covered under a C programming, that is keyword. Keywords are the reserved words that have special meanings. It is a very important part of a syntax and cannot be used as identifiers. For example, int, float. These are the keywords that uh, indicates that it is of int type. Other examples of keywords are for, while, do, etc. Whereas identifiers refers to the name given to the entity such as variable, function, structure, etc. It must be unique. The next is data types. Data types are the declarations for variables that determine the type and size of the data associated with that variable. Example, int a. Here, int is a data type and a is a variable. Int defines that A is of int data type. It can consist a value of integer type. The size of int is 4 bytes. The next is modifiers. Modifiers is used to modify the meaning of fundamental data types, like it indicates how much memory will be allocated to a variable. Example, long, short, sign, unsigned, etc. The next is data conversion. It is used to convert the computer data into one format to another. Example are octal to decimal, binary to octal, octal to hexadecimal, etc. Now the next topic is loops. Loops are used to execute the same block of code several times according to the condition given. They are of three types: for, while, do while. Basically, in loops, we need to initialize a value and give a condition till number of time it will repeat it, and once the block of a code is executed, it iterates itself until the condition is satisfied. Same happens in while as well as do while loop. While loop is also known as entry control loop, whereas do while loop is known as exit control loop. The next is condition. Conditional statement executes a block of code which is true as per the condition. It includes if statement, if else statement, if else if ladder, nested if else statement, switch statement. Switch statement is an extension to if else if statement. For example, if you are above 18, you are eligible to vote, else you are not. Thus, if you input a age that is equal to 18 or above 18, it will display that you are eligible to vote. But if you enter an age that is below 18, 18, it will display you are not eligible to vote. Here, the condition is age, that your age must be above 18 to vote, or else you are not eligible to vote. The next is operator. These are the symbols which are used between the operands. It can be of plus, minus, that is addition, subtraction, greater than, less than, greater than, equal to, less than, equal to, equal to, assignment, etc. Now the next is array. An array is a collection of similar types of data items stored at a contiguous memory location. In array, every value has an index value that starts from zero. Pointers. Pointers are variables that stores the memory address of another variable. The next is function. A function are a block of statements that together perform a task. It is mainly used to reduce reusability of code. Strings. Strings are one-dimensional array of character that is terminated by a null character. The next is the storage classes. It determines the visibility, lifetime, initial value, and memory location of variables. It is of mainly four types: automatic, external, static, and register. Now we come to the second topic, that is C++ programming. So what is C++ programming? C++ is a cross-platform language that can be used to create high-performance applications. It is one of the world's most popular programming language developed by Vijay Strup as an extension to C. It can be found in today's operating system, graphical user interfaces, and embedded system. It is an object-oriented programming language which gives a clear structure to programs and allow code to be reused, lowering development costs. The topics covered under C++ are OOPS concept. It aims to implement real-world entities like inheritance, hiding, polymorphism, etc. And it also aims to bind together the data and the function that operate on them so that no other part of the code can access these data except that function. The next is class. A class is a blueprint for an object. It is a user-defined data type which holds its own data members and member functions which can be accessed and used by creating an instance of a class. The next is object. Object is an identifiable entity with some characteristics and behavior. It is an instance of a class. When a class is defined, an object is created. Structure. Structure is a collection of variables of different data types under a single name. It is similar to a class. Both holds a collection of data of different data types. A struct keyword defines a structure followed by an identifier, that is the name of the structure. The next topic is constructor and destructor. A constructor is a member function of a class that has the same name as a class name. It helps to initialize the object of a class. Whereas destructor is also a member function of a class that has the same name as a class name, but it is preceded by a tilt operator. It helps to deallocate the memory of an object. OOPS has four pillars, that is, encapsulation, abstraction, inheritance, polymorphism. Inheritance means wrapping up of data and information under a single unit. Example, the financial section. The financial section handles all the financial transactions and keep record of all the data related to finance. The next is abstraction. It is one of the most essential features of OOPS. It means displaying only essential information and hiding the background details or implementation. Example, a man driving a car only knows that accelerator will increase the speed of a car, but he does not know how on pressing the accelerator the speed is actually increasing. The next is inheritance. It is a capability of a class to derive properties and characteristics from another class. Example, dog, cat, cow can be a derived class and it acquired properties from the base class, that is the animal class. The next is polymorphism. Polymorphism means having many forms. Example, a man at the same time is a father, a husband, and an employee. The next is, and the last topic is exceptional handling. Exceptional handling is a process to handle runtime errors. We perform exception handling so the normal flow of the application can be maintained even after runtime errors. Exception handling is C++, in C++ consists of three keywords, that is try, catch, and throw. The next, now we move on to the next slide, that is about IoT. So what is IoT? The IoT can be defined as a network of devices that are connected to the internet in order to communicate to each other using sensors and actuators without human interference. It stands for Internet of Things. Here, things are the sensors, actuators, softwares, etc. Now, why IoT is important? IoT is important in our day-to-day life because it makes our life comfortable and easier. From the consumer point of view, IoT has a potential to streamline our daily activities, lower our utility bills by controlling energy usage, help to track health issues, and save our time by providing data from traffic and so much more. From business point of view, IoT has reduced the labor cost, increased efficiencies, speed up decision making, and so much more. Now, we move on to the next slide, that is IoT architecture. IoT architecture consists of three layers: data connectivity layers, data processing and analytics layer, and presentation layer. So what is data connectivity layer? This is the first layer from where the data is collected from IP capable devices as well as non-IP capable devices. These devices are used to forward data. The non IP capable devices in such are Bluetooth, which cannot send data directly to the cloud. Thus, it makes the use of gateway to send the data. A gateway acts as a mediator. It can be both wired or wireless connection. The next is data processing and analytics layer. The data sent from the connectivity layer is sent to this layer where data is analyzed, pre-processed, and stored here before being sent to the data center. The last layer is presentation layer. This is the third layer in which it is presented that is the analyzed data is sent to the end user and business connectivity takes place. Now we move to the next slide, that is the challenges of IoT. As the demand of IoT is increasing, there are various challenges as well. So this slide consists of challenges and how to overcome these challenges. The first challenge is addressing. Thus, the solution is publishing and subscription. Thus, when we want to send, we publish, and thus when we want to receive, we subscribe. The second challenge is scale. The solution of this is cloud. We use cloud as per our requirement and only pay for the services that we are using. It cloud provides pay as you go service. The third challenge is connectivity. The solution for this is queue, that is to handle traffic. The fourth challenge is data volume. The solution for this is cloud storage. It provides a large space to store a large volume of data into it. The fifth challenge is device size. The size of the device are increasing because of the internet. Thus, AM, AMQP or MQTT are used, which requires less internet and it is a lightweight protocol. Thus, the size of the device is reduced. Now we move on to the next slide, that is embedded system. So what is embedded system? Embedded system is a combination of hardware and software which is intended to do specific tasks. That is, hardware plus software plus specific task is equal to embedded system. Here are some examples of embedded system: smartphones, washing machine, traffic lights, robots, car, laptops, etc. Now, what are the components of embedded system? Embedded system includes sensor, analog to digital converter, processor and ASICs, digital to analog converter, and actuator. So what is sensor? A sensor is a device that measures the physical quantity and convert it to an electrical signal which can be read by an observer or by any electronic instrument like an analog to digital converter. A sensor stores the measured quantity to the memory. The next is analog to digital converter. An analog to digital converter converts the analog signal sent by the sensor into a digital signal. The next is processor and ASICs. Processor process the data to measure the output and store it to the memory. The next, data to analog converter. It converts the digital digital data fed by the processor to analog data. Actuator. An actuator compares the output given by the digital to analog converter to the actual expected output stored in it and stores the approved output. Now we move to the next slide that includes project requirements. So the project requirements are garden light control, temperature control system, and water inlet and outlet valve control. So what is garden light controller? It controls the brightness of a light based on the ability of the sunlight. Brighter the sunlight, lesser is the brightness of a light. Temperature control system. It controls temperature of a system by turning on or off cooler and heater of the room. Water tank inlet and outlet valve control. Remote control of level of water inside the tank. If water level falls below 2000 liters, turns on the inlet valve and switch off the inlet valve when the tank is full. Now the next topic is tool required. Tool required in making of this project are Arduino Uno, Pixel Lab, Virtual Serial Port, Blink mobile application. Arduino Uno is a hardware device. It is used as a microprocessor or a microcontroller which can store up to 32 kilobytes of memory. Arduino IDE is software which is used to write the program. Then this program is uploaded to the Arduino Uno. Pixel is a real-time emulator of development board with Arduino IDE for programming the microcontroller's board. The purpose of Pixel is to emulate real hardware. It does not have any source code editing support. It supports several devices that can be connected to the board for simulation, such as LED's push-up button for simple output and input, and some more complex ones like the Ethernet shield for internet connection. The next is Virtual Serial Port. It is a software solution that allows you to create virtual COM port and connect them to each other using software-based virtual null modem cable, or connect them to different serial applications and virtual device via named pipes. Last application is Blink mobile application. It is a full suite of software required to prototype, deploy, and remotely manage connected electronic devices at any scale, from personal IoT projects to the commercial projects. With Blink, anyone can connect their hardware to the cloud and build a no-code iOS, Android, and web application to analyze real-time and historical data coming from devices controlled them remotely from anywhere in the world, receive important notifications, and much more. Now the next is equipment required. This is a CLCD which displays the value. This is a LED. This is a LDR that controls the light. This is a cooler and a heater, and this is an Ethernet connector. Now we move to the next slide. That is home automation. So, what do you mean by home automation? Home automation is a network of hardware, communication, and electronic interfaces that works to integrate everyday devices with one another via the internet. Each device has a sensor and is connected through Wi-Fi, so we can manage them from smartphone or tablets, whether we are at home or miles away. You must have heard about that we can manage our electronic equipment such as fan, lights, refrigerators, ovens by sitting in our office as well. So this is an example of home automation. The most common application of home automation includes garden lights, temperature system, and water tank. So what is garden light? Garden lights uses LDR, that is light dependent resistor, which is used to sense the ability of the sunlight and takes the reading. These readings or data from LDR are sent to the microcontroller. As a result, we observe that there are variations in the brightness of the LED, which resembles controlling garden light based on the ability of the sunlight. There is a bar in a LDR which we either push up or push down to control the LDR or LED. Temperature system. The temperature control system consists of a heating resistor, a LM35 temperature sensor, and a cooler, which resembles a temperature control system at home. It is used to read the temperature from the temperature sensor LM35 and display it on the CLCD. It controls the temperature of the system by turning on and off the temperature and cooler through the Blink IoT mobile app. Working of temperature control system includes: it displays the values on the gauge widget and CLCD. If the button widget is at logic high, it turns on the cooler and heater, and if it is at logic low, it turns off the cooler or heater. If the temperature is more than 35, it turns off the heater and sends notification to Blink IoT app and displays the same on CLCD. The next is water tank. Water tank reads the volume of the water in the tank through serial communication and displays it on the CLCD. It is used to control the volume of the water in the tank by controlling the inlet and the outlet valve by sending commands through serial communication. CLCD is used to display volume of water in the tank. The working of water tank includes It reads the volume of the water in the tank by sending commands through serial communication and displays the volume of the water on the gauge widget and CLCD. It detects the changes in the logic level. If the button widget is at logic high, it turns on the inlet or the outlet valve by sending commands to serial communication, and if it is at logic low, it turns off the inlet outlet valve by sending commands to serial communication. Reading the volume of water in the tank by sending commands to serial communication. If the volume of water in the tank is less than 2000 liters, it turns on the inlet valve and sends notification to the Blink mobile application and displays the same on the CLCD. Now, uh, next is the project demo. This is my entire project setup. This is a Pixim lab. This is a serial tank, serial remote tank. It is a setup of my entire project that consists of a CLCD, LED, LDR, cooler heater, that is temperature system mainly, and the Ethernet connector. And this is the Blink application that controls my entire equipment. Now we'll move on to the uh, demo of the project. This is the entire code involved in the in my project. Home automation blink control INO, IDR.cpp, IDR.h, then main.h, then serial tanks.cpp, serial tank.h. These are the extensions mainly, the temperature systems and the temperature system.h. Now we will first export compile binary to see whether that code is compiled successfully or not. If it contains error, then we will rectify it, and if it's correct, then it will compile successfully. So it's compiling right now. It may take a little while. Now, since the code is compiled successfully, now we'll move on to the Pixim lab to upload the code. So here's the Pixim lab. We need to create ports. It's created COM1 and COM2 are my ports that I will be using. We'll load the hex file. This is my hex file. It's loaded now. It's actually loading. Just a minute. No, it must be loading. Now I will configure COM1. It's done. Then tools, spare parts, and then a serial. Now let it be here only. Now the next we will go for serial remote tank. Here we will connect this. Now we show it's working. I need to reset this. Yeah, now it's okay. Now I will connect my phone. This I will connect my Blink app, Blink with the code. Now, this is my project setup. This is a Pixim lab. Here, we have loaded the hex file and configured the convent. Now, this is a setup, and this is a Blink app. As we click open on this, there is a issue. Now, see, as we click on off the cooler button, click off it's off. As we click on, the cooler starts rotating. It's visible like cooler on. See, this is LDR which controls this LED. As we take it down, the lights get dimmer. See, as the bar is scrolled totally down, the lights get dimmer. And as we take it up, we will see that the lights will glow. See, the light is glowing now. Now we'll control our cooler. Now we will see that as sorry, there was a connection error. Now we will see that as the bar is scrolled down, you will see that a light will slowly get dimmer. I have kept it down. You will observe after some time that the lights get totally dimmer. See, it's now off. Then, as the intensity of the sunlight decreases, the lights will glow up. See, intensity increased, now the lights will glow up. See, can you see this? Light is glowing now. Now we will control the cooler and the heater with the Blink IoT app. As we click on the cooler on button, you will see that the cooler is moving. Just see, it's moving now, and the here it's showing that cooler is on. And if we switch off, the CRCD will display that the cooler is switched off. Taking a time. Now we switch on the heater. It will see both the cooler and the heater button is on. Thus, in CLCD is showing that the heater is on, and as we click on off button, the CLCD will display that the heater is switched off. It will take a little time, but just wait. See, it's displaying the heater is off. See, the cooler is moving now as the switch is on. I think there's a error in displaying the pink IOT. I need to now we move to tab 2. The volume of the water is increasing, and as soon as it reaches its the volume 2000, now if we on the outlet valve and close the inlet, then The water will be going out, and you can see your notifications as it is decreasing. If both the inlet and outlet valve is on, it remains constant. And that's all my project. Now, let's move to the next slide, that is a conclusion slide. Using Blink IoT application and Pixel Lab simulator, I simulated home automations where LED temperature system serial tank resembles light, heater, cooler, and water tank in a real time. CFED acts like a dashboard used for displaying the events widgets from Blink IoT app like button widget are used to control heater, cooler, and inlet valve, outlet valve. Gauge widgets are used to display the temperature and the volume of the water. Thank you.